All right. Put it here. OBS thing. Okay. Welcome. Good morning, anyone who is watching along. Let's go to the browser. First of all, welcome. If you're new and you don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. First of all, thanks for checking out the stream. If you are new, then you may not know what the stream is about. Typically, I work on stuff related to CircuitPython. You can find out more about CircuitPython here at the main website for it, circuitpython.org. This is basically a version of Python that is designed to run on tiny computers called microcontrollers. Typically, the way it works, you will plug these devices into your computer with a USB cable. It shows up like a thumb drive, a removable storage drive. There's a Python code file on there, code.py. You can edit that file inside of whatever text editor you want. When you save it, it will interpret and execute that code for you. The microcontroller, I should say, will interpret and execute that code for you. And your code can interface with whatever other hardware peripherals you want to hook up to your microcontroller. So some of them are very general purpose. You pretty much have to hook up something else for it to do much of anything at all. Others are more purpose-built, like this macro pad or this little e-ink badge or this matrix portal here, which is made for Hub 75 matrices. So they do have a little bit of generic pins available, so you can hook up some of whatever you want, but the primary purpose is this 2 by whatever it is, 8, 12, 10, I don't actually know the connector, but 2 by whatever for connecting up to those Hub 75 matrices. So whole gamut of different devices here that support CircuitPython 666 right now, 661 right now, if I could read. Adafruit is primarily the entity that sponsors CircuitPython. CircuitPython is an open source project. All the code is published under open source licenses on GitHub. Anyone's allowed to take it, use it, fork it, modify it, do more or less whatever you want with it within the scope of the MIT license, which is quite permissive. But Adafruit does pay a team of folks, including myself, to work on that software. So if you would like to help support them in the open source software that they support, like CircuitPython, as well as lots of other Arduino drivers and other things, one of the easiest ways to do so is by purchasing hardware from them, which you can do at their website, adafruit.com. Later on today, 4 p.m. Eastern, 1 p.m. Pacific, if you check back onto the place wherever you are watching me right now streaming, you should find at this time later today, 4 p.m. Eastern, 1 p.m. Pacific, JP's Product Pick of the Week, where you can not only help support CircuitPython and the other open source software that Adafruit aids, like supports, pays people to work on, you can also get yourself a great discount on whatever the product of the week is, where you can stock up on some cool stuff for cheap. What is up, my friend, Royal Bengali, over in the YouTube chat? Nice to see you this morning, my friend. Let us go into the IDE first. So I am starting out today. We are going to try to whip up this Flanger effect PR and make sure everything is good with it and try to get it submitted. Depending on how long that takes, I will work on something else afterwards, but we will see. And I think possibly it shouldn't take too terribly long, because I did do some of this cleanup and stuff the other day. So one thing right now is the frozen modules are different. I wonder if I can just quickly isn't there an update frozens or something? Let's start here. Maybe this will do it. I don't remember. Well, yeah, the frozens are submodules, I think, so that should maybe work. Yeah, okay, totally. Nice. So that gets us down to just our own changes here for Flanger, which is nice. So yes, we added Flanger to audio delays, and so that now shows up as a class and a include in there. Whoops. Fine, so we list that there. That way it's like importable and everything, shared modules. And then this is all new code, so the main thing we would be looking for here is to make sure the doc strings are okay. and I'll test this out as well. In fact, why don't I start with testing it out, because that's a little bit more interesting than just me reading over doc strings. So Flanger is a new effect module that I'm working on that implements an audio flanger, which I don't know. I think this is a common thing, although I will admit to not, like, most of the stuff I read into about it was about software implementations, not the effect itself. Mixing two identical signals together, one delayed. Okay. Yeah. So it's kind of playing a thing on top. It's almost like a chorus that doesn't go for very long, and it also, I believe, it sweeps. Yeah, varying the time delay. Maybe it doesn't have to sweep, but it can, and the CircuitPython implementation does, or at least also can. And this as well, feedback. So part of the output signal is fed back to the input. Okay, yeah. So this flanger effect here, I've implemented this. I have a Metro RP2350 connected to my computer here. I don't have the top-down camera today because really there's nothing to see besides the Metro. Everything's going to be audio on the PC and stuff. So Adafruit used to be such a famous channel, not so much anymore. I don't know. Okay. Not really here to be famous, just here to work on open source software and make cool stuff. I can only speak for myself, really, though. Grab the Metro. It's under A. Okay, while that build's running, we can start reading over this. So init, it's got a bunch of parameters to affect the flanger. Delay milliseconds, rather max delay, and then delay. But yeah, I think the way this is set up with max and regular, the idea here is, and it took me a minute to figure this out, but I think the intent of this is that you could set max, and it's really mostly useful to set max if you are in fact using a block input, some kind of dynamic thing that is going to sweep the value of delay milliseconds, and then this max will act as a cap for you. So if you're sweeping and you have less control over the thing you're sweeping, it sweeps outside the range that you really want, then you kind of cap it with this as well. There's no min, so you don't get the clamp on the other side, which tough. Let's see, what is this? Audio flanger. I want to make the build here. I mean JN. Did I delete something there? This is in Flanger C, shared module 296. Yeah, definitely there's just a floating in. Let me look in the code over here. Although it's gonna be there right now, actually, though. You list all the local branches. List local branches. Branch. Flanger. What is up, my friend? Lake Rotal. Hello from the world of France. Nice to have you joining us from over there. Hope you're having a nice day. Get checkout. So I guess this is just not... Well, it's not tied to a remote, I guess, which is why... Yeah, okay, I see. Okay, so now this should be checked out to where I think, so I can check in here. Module... Good delays. The question is, does this have just an in also, or did I at some point mess it up, basically? Well, the code's not the same. Well, so it does have an in that gets declared up here, in fact. We have a sample. I changed it to num bytes. And it just didn't reassign there. Or down here. Makes sense. I wonder if we should have done clean. That's probably fine. Yes, thank you. Good. Hope everyone else is too. And sorry if my English is bad. Hey, no worries, my friend. Let's see. Go to bootloader. And I can let go. I'm so used to doing the Ting EP2350 that I'm like in this, gotta keep holding the thing when I go to bootloader mode. CP build Metro. And did a T instead of an R for Ting boot. Alright, so let's get this on there.